the General Manager and Senior Vice President of the Software and Services Group, speak first, and Anish Chandrasekhar, General Manager and Senior Vice President of the Ultra Mobility Group, will speak as well. And then we will take time for Q&A at the end. So please do stay for that if you do have questions. And I'm going to hand it over to Renee now.
All right, good morning. Sorry for late getting started here. We are going to talk for, I don't know, 20 minutes. We're going to show you some demos of our progress, and then we're going to open it up for Q&A. And I know you all want to ask us questions about Nokia, so be patient. We'll talk about it. I'm going to point this back here, and hopefully we're not going to have interference. Okay, someone's standing right in front of the computer. There we go. Go again. It's not going to work with the gentleman standing in front of him. Okay, I just want to remind you before we get started a little bit about Intel, right? So we have a lot of strengths that we're very, very well positioned and very excited about our progress in mobile. We've heard the feedback and we're going to tell you where we're going, but before that I just want to remind you a few things. We've been working on our architecture for well over 20 years, and one of the unique things about our architecture is its ability to cross across multiple segments of computing. And Anand will tell you how we're doing specifically in mobile computing, but as you well know, one of the great things, and this is going to come back as we talk about ecosystems, is that our architecture is binary compatible and forward and backward compatible across our product line, which for developers is a very important piece of how you write applications and they move across different segments of computing. I'm going to talk about our software investments just as a background to some of the announcements we have today, and then of course, Anand's going to touch base on how we're doing with our manufacturing and process technology leadership. I think you all know that we're doing well there. We expect to continue to do even more as we move into new technologies. We believe that our leadership position will continue, and that will play very heavily into where we're going in mobile technology. And then finally, I want to talk about our ecosystem. I'm hearing a lot of discussions about ecosystems, so I'd like to give you a point of view of where Intel is in our ecosystem. So with that, I don't know if the clicker's going to work in this room with all the interference. The first phenomena that we think is really important to where Intel's headed is that communications and computing have come together. People talked about convergence for a long time, but it's happened. But more importantly, we're moving towards computing. So a lot of the applications and user experiences and the things that people want to do with their mobile devices are moving more towards compute-intensive applications, experiences, usages, video, imaging, those kinds of things. And we believe that architecturally we're in a very good position to deal with those kinds of usage experiences. And that's really the underlying point of view of where we're going in mobile technology. And the demonstrations we're going to show you today are about the user experience that can be created using Intel architecture in mobile, in in-vehicle infotainment, in IPTV, in tablets, in PCs, across all the different architectures. All right, can we go forward? Our strategy is a solution strategy. It's not a point product. So we are working on entire up and down the stack, from silicon, platform level, software, which I'm going to talk about some more, and services across an entire array of devices. Today we're going to show you one of many of those because we can't demo all of them. I want to invite all of you to either go by the Intel booth or the Meego Pavilion to see all of the different platforms that Intel Atom technology is in and Meego is in and other products of ours. Okay. I want to take a second and talk about the developer ecosystem. We have 15 million developers on Intel architecture today. We have 23,000 ISVs in our developer program already, and as you can see in our App Up program, which is targeted very specifically at mobile application developers, we have 38,000 developers today. We feel very confident about where we're at in ecosystem building. It's something that we have been at for a long time. We have the third largest developer program in the world. We have many, many, many developers that know our architecture, have worked with Intel, are comfortable. We have tool chains for them. We have complete developer support for them. And most importantly, we have an application distribution environment that we announced last year, AppUp. Just to give you some data, I think this will all be available to all of you, and it's on our website, so you get a little bit of perspective about where we are in environment and ecosystem building. We'll talk about software platforms for 1 second before Anand talks about where we're at with silicon. Our strategy for the last 2 decades has been and continues to be port of choice. What we mean by that is that all operating environments run on Intel silicon, and nothing has changed. We run Android. In fact, if you don't know, we've made tremendous progress in Android on our mobile platform, and we're very, very happy with our performance. We've been doing benchmarks on our handset silicon, and on average, we're seeing twice the performance of our competitor using Android builds. So we're very, very happy with our Android progress. We're going to show you some of our Meego progress today, where we are going to continue with Meego. We will continue going forward. Today we're going to show you one of the user experiences that's being released, and we'll move forward with our efforts there. We of course run Windows, all other Linuxes. Those of you that follow Intel know that we were one of the original founders of Red Hat Linux. We know Linux quite well. We're one of the leaders in the open source community. That's why it isn't surprising that we would continue on with Meego on our own, with our other partners that we have beyond the one that you most want to discuss with us, and that we also are doing so well, of course, with Android, which the underlying technologies are very similar. We've acquired Wind River, which is the leader in embedded system software. We will continue with their efforts as well, so you'll see many, many embedded devices, embedded communications devices based on Wind River's technology as well. And as Chrome comes available from Google, we'll be supporting that. I mentioned the application distribution environment, AppUp. We launched this AppUp 1 year ago. It went gold this fall, so less than 6 months. I gave you some of the stats, but the most important things that I want you to think about is not just how many developers we already have, and we're just now starting to ship devices. It is available now for Meego, starting today for tablets. We'll be adding handset support as well. We have worked with the community to move the top applications that people know from the iPhone environment, from the Android environment, into supporting Meego as well. We are excited. One of them, of course, is Angry Birds, which is available now. But more importantly, the applications that we're moving into this development environment work across multiple platforms. So anything that we have running on x86 will actually work on a laptop, and in the right form factor can work on a tablet and can also work on a handset. So we're doing a tremendous amount of this work. This is just now going to start coming out. We have several thousand apps today, and we will continue to build the application developer environment. If you don't know about AppUp, I'll just give you 2 more seconds on it. We have a very unique model. You can go to appup.com and download apps if you'd like. But we also, our validated application catalog serves other people's app stores as well. So if you were to buy a device, say at Dixon's in the UK, and you wanted to connect and get applications for that netbook, you would be getting it through the engine of AppUp that would be serving Dixon's store. So we believe it's an opportunity for application developers to have multiple points of monetization and multiple points of distribution for Intel devices will be able to get applications. With that, I want to turn over to Anand and let him give you an update of where we are in our silicon technology for mobile, and then I'll come back and we will show you some new products.
Thanks, Renee. Okay. Thank you. Good afternoon. Can you guys hear me in the back? Yes? Perfect. Okay, so I wanted to pick up where Renee left off, and I'll start talking about the silicon a bit. Right? First of all, Atom. Atom is a silicon architecture that we engaged on developing, and the first products came out in 2008. Those products were clearly targeted at netbooks and very small disposable PCs, if you will. We came back and improved upon that last year with products that would, with Morristown in particular, the products that would head into the tablets. Tablets are expected in the marketplace this year. And ultimately, our goal is to get into the smartphone domain as well with Atom, and I'll talk a little bit further about that today. The beauty of Atom is the same beauty that we have with the rest of all of our silicon products, core on upwards. Same instructions and architecture. So if you write an application on our PC, that same application, without changing any instructions, will run on the handset as well. So that's very powerful from a developer ecosystem standpoint. When you talk about Apple, many of those applications, as they get developed and written, today those are for netbooks and tablets, they will just run on the smartphones, utilizing our Atom solutions. So that's the beauty. Sorry, are you guys gesturing something?
Can you give him the handset? It's just the feedback is coming back.
You're going to take this off?
Yeah.
Okay. All right. Perfect. So let's keep going on this. And the fundamentals of the Atom family are, we started shipping into netbooks, we started shipping also into TVs, consumer electronics. You saw the smart TVs emerge last year. That has our Atom-based SoCs in it. And this year we'll be starting to ship our silicon that goes into, in production, that goes into the smartphone. Does this work?
Not so much. I usually
All right.
say
Thanks. The fundamental foundation of silicon technology is obviously process technology. Right? This is not a new slide. You guys have probably seen this before. It shows the curves on power and performance on Moore's law on our technology, 90 going to 45, going to 32, going to ultimately 22. The key thing I want to talk about here is the following. With our 45 nanometer technology, we introduced a fundamental change in transistor technology, high-K metal gate. Now, you might be wondering, okay, why is that important? It's important because every single semiconductor manufacturer has one challenge that is extremely common, particularly as it comes to mobile devices. The more transistors you pack onto a chip, your power goes up exponentially. Getting a handle on that power, particularly as you go from the current generation node to the next generation node, is exceedingly important, particularly within the leakage power tank. Leakage power is that power that is consumed by the silicon when it's doing nothing. Right? So very, very important to get that leakage power down, particularly as you have a lot of transistors. High-K metal gate is a fundamental breakthrough which allows a reduction in leakage power by a factor of about 100x. Right? So without that kind of a breakthrough, it's going to be challenging for anybody in the industry to get leakage power down as we move from node to node to node. We, to date, are on our second generation process technology that utilizes high-K metal gate, that's 32 nanometer, and of course our 22 nanometer will have it as well. So by the time our competition comes in with their solution, which has high-K metal gate on it, we'll be on our third generation, and we will have shipped 1 billion units utilizing high-K metal gate transistors, and they will have shipped a grand total of 0. Very important, fundamental breakthrough in technology that is important as you're building low-power transistors. Next slide, please. Okay. So, again, why is this performance important? And the transistor technology important? Let me do a little bit of a quiz here. How many of you guys use a phone that allows you to access the internet? Can you just raise your hand? Okay, pretty much all of you. Okay, leave your hand up, please. Leave your hand up if your hand raised. Okay. How many of you find that your phone dies out of battery in a day? Your hands are still up. Okay, so most of you. How many of you find that your phones die out of battery in 2 days? Most of the hands went down. So, now why do you think that is? You think, raise your hand if you, I'm going to give you a multiple choice question. And raise your hand if you think the answer is either one of these. Your phone battery is dying because it's in standby. And the standby power is high, therefore it's going down. If you think that's the answer, I'm going to come back to that. That's option A. Option B is your phone battery life is dying out because you're using it more, you're accessing the web, you're browsing, etc. So how many, and that's option B. How many of you think it's because option A? Raise your hand if you think it's option A. Okay? All right. There are a few hands that went up on option A. How many of you think it's because of option B?
Most of you guys, all right? Well, option B is correct. Your phone battery life dies not because you're in idle. It dies because you're actually doing something with it. If you're not doing anything with it, then up until now, most phones manufacturers advertise standby life in days or weeks, right? That's table stakes. So news. You want to be able to do these sorts of things. Fastest browsing experience, fastest application launch times. I'm not going to read all of these. Now you might wonder, why is that important? And why is Anand talking about that in a phone? It's important because if you have the lowest standby power and you have the fastest performance, you can do something which if you're a human, you did it at work, you'd be fired. But if you're a processor, you get rewarded, which is you can get the job done really fast and go to sleep. Okay? I don't recommend you do that at work because you're probably going to get fired. But as a processor, it's a really good thing. Get the job done and then go to sleep. What that I'm talking about is the active power. Active power is what you utilize to get usage, browsing the web, so on and so forth. And on active power, we are the most efficient architecture on the planet. Idle power, everybody has it. We do too. We'll be world class on idle power, just like everybody else claims. But the trick to get your phone to last longer is basically to get active power to be better. And so that's what we do. That's what we spend our life doing. You guys can get the next slide, please. Thank you. It's now working. All right. So Medfield is our 32 nanometer chip. This chip is sampling already. We've been sampling it for several months now to our customers. It will have the fastest processor that you can find. It will have the longest use time. It'll have the longest use time. So active power translates to use time. Standby power translates to you're not doing anything with it. We'll have the same standby as everybody else claims. So if you want to put it in idle and leave it aside for weeks, you can do that with our stuff. You're not buying a phone just to leave it in idle. You're probably buying one of these phones you can actually browse the web and do some of those things. That's the use time. You'll have the longest use time because of the efficiency. We will have super fast computing, rich multimedia, something that matters. All of these phones are basically turning into gaming machines and entertainment devices. We will have that. These phones are also turning into camera devices. You want to be able to take great pictures. You'll be able to do that with our phones. Not only that, our phones will be able to take pictures in the dark and it'll look like you have a 60-watt light bulb on top of your head. So really cool stuff that consumers care about, that's what we'll have. And as I said, we're already sampling. You might be wondering, how do we get pictures in the dark? We recently bought a company called Silicon Hive. Silicon Hive is a world's leader in imaging technology. And we just closed that transaction that got announced today as part of the announcements that we're making. So now I want to show you a little bit about what Medfield looks like. We're not announcing it today, so there's a bit of a sneak peek. I'm going to just speak without the microphone. Hopefully you can hear me. Let's see if this works. What I have in my left hand, this is not Medfield. Okay? So important for those of you guys that are taking pictures, this is not Medfield. Okay. This is Morristown, 2 chips. Okay. What I have in my right hand is Medfield. This is Medfield. So this is the difference between these two. But that's not the only difference. This is the only difference I'm willing to tell you today. Okay. All the other differences you'll have to wait. Right? Oh, you're probably wondering if there is a phone being built on this thing, right? Yeah, just a couple. I'll just hold up this one. This does happen to be an Android phone. It does happen to be fairly thin. Yes, it is possible, message to Warren East, to get Intel architecture into a phone and ship it at a faster level of performance than what he can deliver and at a lower level of power than what he can deliver. You can put that in print. Okay? By the way, if he wants a math lesson, tell him he can call me as well. Doesn't work. Okay. Communications is clearly an important aspect of all of these devices. Whether it's a phone or whether it's a PC. communications is clearly an important aspect of all of these devices. Whether it's a phone, whether it's a PC, all sorts of these devices, netbooks, tablets, notebooks, all of them need comms capability. In the summer of last year, we made the decision to buy Infineon's wireless division. As of February 2nd, they're now part of the Intel family. They're called Intel Mobile Communications. President of Intel Mobile Communications, Dr. Herman Noyle, is here. Herman, if you could stand up. If you could please give him a round. He will join us for Q&A. So we now have the full suite of Wi-Fi capabilities. We have the full suite of 3G capabilities. One of the decisions we made was to acquire Infineon's wireless, bring it in-house, and we wanted to move from a follower position that Infineon had in that category into a challenger and into a leadership position over time. Clearly is an effort that will take some years for us to do it. And as part of the announcement to buy that entity, we said our first step was going to be to accelerate LTE. Clearly important because true mobile broadband requires 100 megabits per second transmission and receive capability. So we wanted to be able to get that. Part of that is accelerating LTE. So what I wanted to talk about is give you a bit of an update on where we are on those products. We are accelerating LTE with Intel Mobile Communications. We are going to be sampling our LTE chip in this year, 2011, and we will be in production in phones for Christmas of 2012. So number one. Number two, we have the world's smallest HSPA Plus chip and the lowest power consuming HSPA Plus chip in production now. Those are product details that are being announced by IMC at this conference. Number three, innovation in this domain also is about being able to deliver products that service providers and customers can take advantage of in a unique way. So IMC is also launching at this conference a dual SIM product where consumers can basically have a SIM card for their professional life and a SIM card for their personal life in the same phone. Very important in multiple parts of the world, very important even in the western parts of the world, and IMC is launching a product for that. Three very significant capabilities, all being accelerated, and we're investing further into that organization so they can move faster and into the marketplace. Intel is also in the infrastructure. We're in every aspect of the infrastructure. 10 out of 10 infrastructure companies in the telecommunication space use Intel architecture, and it's across all of these domains. Routers, switches for voice, network security, wireless, media processing, and the service platform. And today, specifically at this conference, we're announcing that Korea Telecom and Samsung and Intel are entering into a partnership to utilize Intel architecture in their LTE-based deployments. So again, moving forward, not only on baseband chips for the phones and other devices, but also for the backbone in the infrastructure itself. We also invest in companies in the ecosystem to help increase the attractiveness of our platform and enhance the smartness of the mobile platform. These are just a handful of the investments that we've completed over the last 6 months to enable and further our interest in the mobile arena. We've completed investments in Borks. Borks is a system integrator that does a lot of work on Android system integration for tier 1 phone manufacturers. We've completed an investment in them. CloudMade is, as you can tell, a tools company for the cloud environment, very important for phones. Envisage is a company that has sophisticated technology for image processing. Again, very important category for phones in general and tablets, and again, an area we're investing pretty heavily in to take a leadership position. I won't go through all of them, but you can get a feel. SecureKey, as you can tell, is to enable stronger fidelity in secure transactions. Is a great partner technology in addition to what we already have in-house with the McAfee acquisition. So to summarize, if you look at all of those things in blocks, those are all the technologies that go into a smart mobile platform. You have to have great graphics. We have it. You have to have a great processor. We have it. Our 32 nanometer chip will be in production this year, shipping in phones. And we're talking, that's what Medfield is what I talked about. We have to have great imaging. We have that. We talked about the acquisition we just made of Silicon Hive's technology. That's the leading image processing company. You have to have baseband technology that is matching what the market needs. We have the lowest power consumption, smallest chip on HSPA+, and we're accelerating LTE. Now all of that together enables, ultimately, a great user experience. And the great user experience depends on software and what we can do with that. And clearly, everything you have in software needs a fundamental hardware platform, a great hardware platform, and it can take advantage of. Now, to talk a little bit more about how that user experience improves when you have great silicon underneath, I'd like to invite my colleague Renee back up again, and she'll fill in the story.
Thank you. Okay, I'm going to talk a little bit about Meego for 2 seconds, and then I'm going to show you some things. And I'm going to invite Doug up to help me. Meego is an open, unified computing environment, and you've heard us talk about this before, but I want to remind you that our perspective on this is that, first of all, there needs to be an open source alternative that is open for innovation across multiple segments of computing. And that ability to build an experience that connects not only handsets, but tablets and in-vehicle infotainment systems and IPTV, so you can move seamlessly between your device and into your home and into your car, is part of our vision for how we see the Intel unified platform coming together. So Meego is our solution there. It doesn't take away from the fact that we're building lots of Android phones, and you saw that from Anand. We're going to continue with our work, and very specifically today, what we'd like to show you is our new tablet user experience for Meego. And if we can go forward one. So we're announcing the release to developers of the Meego tablet experience. We're going to demonstrate it to you now. And what you should take from that is there's open source project already on handsets. The full user experience hasn't been released, but this will give you a point of view of what the unified Meego user experience will look like. Going forward, I'm going to invite Doug Fisher. Doug up to help me. Doug is the Vice President of System Software and responsible for the Open Source Technology Group at Intel. And this is his product, so I'd like him to share with you a little bit about Meego Tablet.
Thanks, Renee. All right, I can put that back up as well.
Yeah.
So those of you that been to Computex heard me talk at length about our experience in Meego on netbooks as well as tablets at that time. Now the key thing around Meego is how we architected it to be centralized around the individual using the device. Not only how they interact with the device, what we expect them to do with the device, but also updating and learning as they use the device. And so the concepts we built into Meego are really centralized around the user, focusing on them as opposed to the traditional way, which is focused around applications. So that's the key difference between what we've done and specifically in the tablets, you'll see that in the handsets as well, carried forward, is focusing on the user themselves. So let me just go ahead and demonstrate it. I can go through photos, but I can demonstrate what we've done here. And so you have your traditional grid environment that a lot of people are used to seeing. I know it's turned sideways, but I'm going to go to the panel environment, which is more intuitive. So you'll give the user that panel view or with a grid of applications, but we think that users are going to demand a more sophisticated interface that organizes their life, how they operate. And so we've instrumented the tablet into what's called a panel view, which organizes the interactions with the tablet into topic areas. My tablet has the applications that you use most. It has setting capabilities. My Friends contains all your social networking. So this includes things like emails that are important to you, Twitters, Last.fm, all your social feeds are in that panel. The clever thing about this device is it learns as you use it. So if you don't read emails from certain people, you don't follow certain tweets from people, it learns. And it puts the ones that are most important to you, and learns about you, at the top. So you can get access and see right away the ones that are most critical to you. Each one of these panels is independent. So they're live feeds, and they're independent, and you can operate them independently. And so you have your music, your photos, your videos, and the web pages you most recently accessed. All these feeds are live, so you can update these as it learns about what you're doing. And so if you just interact with photos, again, it's a traditional photo viewer that you'd expect to see on a device. One of the things that we've instituted in Meego is the object-oriented nature of it. And so not only do you interact with the application, but we also incorporate an object-oriented mechanism which is almost like a right mouse click, where you touch on the event and it gives you options of things you can do. Whether you want to forward it to somebody, put it in your favorites, add it to an album, you interact with that application right there. And so we were doing this, bringing this concept to every aspect of this device. Traditional devices have you interact with the application. This has you interact with the object. So if you decide you want to call somebody versus Facebook them, you have all those applications associated with that individual that you can participate with them. So we've really centralized everything we're doing in Meego around the user. So that's the key aspects that we're bringing today. In addition, it's multitasking. And Renee and Anand talked a lot about the power of the Intel processor. Because of that power, because this is Meego's built on a true multitasking operating environment, the true multitasking is built right into this device. And so we have, I believe we have some of these here in the room. We encourage you to play with these, get a good sense of what we're bringing.
It's hard to see the colors.
Oh.
It's really dark on them.
It's dark on this thing?
Yeah.
All right, you can hold this up.
They can see it from back of them too.
So those in the back there that couldn't see it, now you really can, but this is the panel view that I'm describing here. And so this is a very unique concept. We think this is going to be how the users expect in the future to interact with their devices. And you can see how this concept is going to be brought forward in handsets, IPTV, in-car infotainment, all aspects of where Meego runs, as Renee described. Meego runs across a broad set of platforms. So the same user concept will be instrumented across all those segments, giving you a consistent interaction with all your infotainment needs. So this is a very, very clever way of bringing that to all those segments. Okay? So with that, I think we'll turn it back over to Renee.
Thank you, Doug.
And there's several tablets in the back. Oh, that's upside down. That's not so helpful. But anyway, go back to the other slide. I just have a couple more comments. So just to be clear, obviously, in light of the industry announcements, I'm not going to take questions on it. We're going forward with Meego. And this is open for developers. It's a developer preview. The tablets, you should expect to see Meego tablets shipping this year. And based on the Atom technology that Anand talked to you about, you would expect to see handsets following. We have several partners that are also in design, and I'll talk about that. But I want to take 1 second and go forward. I don't know if the clicker's working here. And talk about the industry momentum. So we have had a lot of partners involved in Meego. It's an open source project. It's hosted by the Linux Foundation. There are many, many ISVs, other silicon manufacturers, other hardware manufacturers involved in what we're doing. And so it isn't just an Intel effort, it wasn't just an Intel and Nokia effort, it's actually an industry effort. And if you're out reading the blogs and seeing what developers are saying, you would know that there are just many, many people involved building products on Meego in lots of different segments outside of handsets, as well as handsets. So we're excited about the community momentum. I explained to you how many developers we have in our program. Lots of our partners have their own programs. So Meego is more of a viral community effort that's going to go forward. And I'd like to invite Patrick up from Orange to talk about the carrier support for Meego. This is Patrick Remy. Thank you, Patrick.
Thank you, Renee. So yes, a quick word, and I must say that I'm very happy to be here with you and to be able to share a actually very simple message with you. There's been quite a few questions flying around the industry lately about the Meego ecosystem and the support to that Meego ecosystem. Well, let me tell you that at our range, our position is extremely clear. We've been one of the historical supporters for the Meego ecosystem, and when we started looking into that opportunity, Meego was not even called Meego at the time, and that position has absolutely not changed following the recent announcements. And the reason for that is actually very simple. When we started discussing about Meego with Anand and Renee, the vision that we shared with them was that we believed that this industry needed a truly open ecosystem that was providing a level field for all of the players in the ecosystem to express their innovation and differentiation capability, either them being silicon vendors, or operators, or application developers, or even manufacturers. Well, when we talk with our fellow carriers around the planet, or when we talk to manufacturers, well, this need is still there. It has not disappeared because one of the partners within the Meego ecosystem has decided to shift their focus to some other platform. So the need is still very much there. We really need that truly open ecosystem to exist and develop. So the support from Orange to Meego is still very, very clear, and there's no question about this. So that's why I'm really happy to be here on stage with you guys.
Thank you, Patrick. We appreciate that.
Okay, thank you. Okay. To summarize, and then we're going to open it for Q&A, and I'm going to invite Herman to join us on stage. We are introducing the tablet user experience today. We're sampling Medfield as Anand said. We're celebrating the LTE products, shipping HSPA, sampling the dual SIM product that Anand talked about, and we're announcing our collaboration with KT and Samsung in the LTE trial.